Welcome back, everyone. Today we'll be covering Chapter 15, Refrigerant Recovery and Recycling. Once again, we'll be using slides out of Goodhart Wilcox Publishers' Heating and Cooling Essentials, 4th edition. Make sure to pick up this book if you don't already have it. It'll help you follow along and do the questions at the end of each chapter. Our objectives will be to explain the ozone depletion problem, recognize CFCs, HCFCs, and HFCs, comply with the 1990 Federal Clean Air Act, state equipment and technician certification requirements, use recovery cylinders properly and safely, recognize recovery and recycle equipment, properly perform recover and recycle procedures. Ozone depletion. Growing concern about the damage CFCs and HCFCs can do to Earth's atmosphere. Ozone protects life on Earth from harmful UV radiation. Ozone helps maintain stable Earth temperatures. CFCs lift chlorine atoms to the ozone layer where they break down ozone molecules. Ozone depletion potential, or ODP, is a measurement of a refrigerant's ability to destroy ozone. CFC equals high ODP, HCFCs equal low ODP, HFCs equal no ODP. And on the right, you have an ozone depletion potential chart. Global warming potential, or GWP, greenhouse effects, occurs when long wave radiation from the sun reaches the earth but cannot escape, causes gradual buildup of heat on Earth's surface. The higher the GWP, the greater the risk. And on the right, you have a global warming potential chart. Montreal Protocol is an international agreement to sustainably reduce and eventually eliminate the production of ozone depleting CFCs. Production of all CFCs to end by January 1st, 1996. Equipment produced after January 1st, 2010 must be HCFC free. And on the right, you have the HCFC phase out schedule. Clean Air Act, or CAA. Federal law passed in 1990 served restrictions and penalties for venting refrigerants to the atmosphere. U.S. EPA implements and enforces the regulation. And on the right, we have a summary of the EPA compliance states. Types of venting permitted. De minimis, or minor quantities of refrigerant. Normal operation emissions. EPA requires the repair of sustainable leaks. Mixtures of nitrogen and refrigerant used as holding charges or leak test gases. Small releases of refrigerant resulting from purging hoses or from connecting or disconnecting hoses. Refrigerant leaks. Owners of equipment with charges over 50 pounds are required to repair substantial leaks. Industrial process and commercial refrigeration sectors, 35% annual leak rate requires repair. Comfort cooling, chillers, and other equipment, 15% annual leak rate requires repair. The 3Rs. Three main procedures concerning a system's refrigerant charge. Recover. To remove refrigerant in any condition from a system and to store it. Recycle. To clean recovered refrigerant for reuse by removing moisture and contaminants. Reclaim. Restores recovered refrigerant to a level equal to a new product specifications. Recover. Illegal to vent refrigerants into the atmosphere. Recovered refrigerants normally return to same system after repairs are finished. Does not address the quality or reuse potential. When to recover. Before the system is opened for repairs, before disposing of any system or components, when removing excess refrigerant from a system, before pressurizing a system for leak detection with an inert gas. Recycle. Circulates through filter dryers, removes moisture and contaminants, may require several hours, does not have to meet cleanness specifications, limits reuse to the same system or another system belonging to the same owner. Reclaim. Necessary if refrigerant is to change ownership. Reclaiming cleans to the ARI 700 standard of purity, normally available only at manufacturing or reprocessing facility. Safe disposal requirements. Before dismantling equipment for disposal, it must have refrigerant recovered in accordance with EPA requirements. Equipment that enters the waste stream with charge intact is subject to certain safety disposal requirements. Final person in disposal chain is responsible for ensuring equipment refrigerant is recovered before final disposal. Record keeping requirements. Technicians. Servicing appliances with 50 or more pounds of refrigerant must provide owner with invoice indicating amount of refrigerant added. Must keep proof of certification at office. Owners of appliances containing 50 or more pounds of refrigerant must keep service records. Record keeping requirements. Wholesalers selling HCFCs must keep invoices that indicate name of purchaser, date, and quantity of refrigerant. Since 1994, sales restricted to certified technicians. Reclaimers keep records of names, addresses of individuals sending them material and quantity. Annually submit an activity report to the EPA. Hazardous waste disposal. Recycled or reclaimed refrigerant are not considered hazardous waste under federal law. Oils contaminated with CFCs are not classified as hazardous waste, provided they are not mixed with other waste subject to CFC recycling or reclamation, not mixed with used oils from other sources. Motor vehicle air conditioning. All persons servicing motor vehicle air conditioning units must be certified in refrigerant recovery, recycling, and proper use of approved equipment. Servicing includes repairs, leak testing, topping off, and dismantling. Can be obtained through home study program, booklet, and open mail in test. Technician certification must become certified by passing EPA approved tests. Passing score of 70% is required to be certified. Technicians is responsible to comply with any EPA regulations changes occurring after certification. Failure to comply with EPA regulations can cost as much as $25,000 per day per violation. Types of EPA technician certifications. Type 1, to work on small appliances. Type 2, to work on high pressure appliances. Type 3, to work on low pressure appliances. And Type 4, universal, to work on low and high pressure equipment, including small appliances. Side note, guys, I do recommend that everyone go and get their EPA license if they haven't gotten it yet. You could go to any parts house and buy the test. They'll give you the study equipment. Study, call them, schedule a test, come back. And everyone should try to shoot for your universal. Once you have your universal certification, you'll be able to work on all types of equipment. Test format. Most tests contain all 4 sections. Each section has 25 multiple choice questions. Minimum passing score is 70% in each section. Certified in sections where passed. Must achieve passing score in core section to receive any type of certification. Passing score is in all 4 sections earns a Type 4 universal certification. Test sections. Core section covers general knowledge about stratospheric ozone depletion, rules, regulations of the CAA, Montreal Protocol, and the 3 R's, recovery, devices, substitute refrigerants and lubricants, recovery techniques, dehydration, recovery cylinders, safety, and shipping. Sections 1, 2, and 3 contains questions pertaining to types 1, 2, and 3 certification respectively. More test information. Closed book, no time limit for completion. Average time required is an hour to an hour and a half. Personal information required for exam. Picture identification, social security number, home address, employer's name, and address. EPA approved testing organizations located throughout the United States. Equipment certification. EPA requires recovery units manufactured on or after November 15, 1993 to be tested by the EPA-approved testing organization to ensure equipment will achieve required vacuum levels. Recovery requirements. Technicians are required by law to use recovery systems to evacuate air conditioning and refrigeration equipment to establish vacuum levels. Technicians repairing small appliances are required to recover 80% to 90% of the refrigerant in the system, depending on the status of the system's compressor. Expectations to recovery requirements. If evacuation to required levels is not attainable, isolate leaking components from non-leaking components. Evacuate non-leaking components to the required levels. Evacuate leaking components to the lowest attainable level without sustainable contaminating the refrigerant. The level cannot exceed 0 psig. Recovery cylinders. Heavy duty refillable cylinders. DOT specs. Color coded, gray bottom with yellow top. Avoid mixing refrigerants. Label each cylinder permanently and clearly. Must be retested and recertified every 5 years from stamp date. Recovery cylinders have 2 valves. Liquid valve has a dip tube to the bottom, full at 80% capacity. Capacity rating is stamped on cylinder, sometimes reads WC for water column. May have built-in safety devices, monitor process closely. Hydrostatic pressure. Fill cylinders carefully to prevent equipment damage and physical injury. Hydrostatic pressure in an overfilled refrigerant container can cause the cylinder to burst. Burst cylinders will always damage equipment. Being caught in the explosion can lead to injuries and even death. Recovery equipment. Used to avoid venting of refrigerant into the atmosphere. A refrigeration system is designed to remove and store refrigerant in a refillable cylinder. Recovery and recycling systems. Some are capable of removing liquid or vapor, others remove vapor only. Removal in liquid state is faster. After all liquid is removed, remaining vapor must also be recovered. EPA requires to use low loss fittings. Understand the steps involved in the refrigerant recovery. Recovery procedure. Recover only one type of refrigerant into a recovery cylinder. Clearly label cylinder to avoid mixing refrigerants. Become familiar with a recovery machine's controls before using it. Recovery procedure. Length and diameter of hose and fittings affects efficiency and time required. Longer hoses and smaller diameter hoses cause great pressure drop and increase recovery time. Keep in mind interdependent pressure temperature principles for efficient recovery. Low temperature causes low pressure for faster recovery into a recovery cylinder. Passive recovery method. Used on refrigeration systems with a working compressor. System's compressor is used to push the refrigerant into the recovery cylinder. Active recovery method. Used on systems without working compressor or the liquid refrigerant has been removed. Recycle units. Remove contaminants from refrigerant prior to returning into system. Contain a liquid pump. Most units use one or more filter dryers for cleaning refrigerant. May take 4 to 6 hours of recirculation to remove all contaminants. R&R systems perform both recovery and recycle operations. Recycle unit operation. And here shows a chart, a flow chart of how the recycle unit operates. Capture methods. Refrigerant stored temporarily in another part of the system not needing repair. So an example of this would be, let's say on a split system that you have to work on the evaporator section, you could pump down your refrigerant and store it all into your condenser and close off the service valves, of course. And then now from out of condenser onto your evaporator, that whole line set, your evaporator will have no refrigerant. You could do repairs and then just pull a vacuum on that section. And once you're done, open up the valves and all your refrigerant will be flow back into the system. not a recovery procedure, traps most refrigerant in condenser or liquid receiver. Pump down procedure. Closed valve at liquid receiver outlet valve. Compressor evacuates refrigerant from the low side and stores it in the liquid receiver. Turn off compressor. Close liquid receiver inlet valve or other high side valve to isolate and contain. Leaves low side in a vacuum. Pump down procedure. And here shows a graph of what you would be doing. Atmospheric balancing. Used to break vacuum so system can be open for service and prevent contamination. Two basic methods. Bypass a small amount of high side vapor through the gauge manifold into the low side. Use liquid receiver service valve to throttle vapor into the low side of the system. A small amount of liquid makes a large amount of vapor. Only 1 to 2 psi is needed. And here shows your manifold gauge and you cracking and throttling refrigerant into your low side gauge. Accessing high side after pumping down. Capturing refrigerant in the condenser. Used when a system does not have a liquid receiver. Shut-off valve must be available at condenser outlet to the liquid line and must be closed. System is pumped down into the condenser. Compressor is shut off. Discharge valve is front seated. Condenser will hold normal system charge and not be completely full. And here is a picture showing capturing refrigerant in a condenser. And this is the end of the slideshow. I hope it was helpful. Remember to do the questions at the end of chapter 15. I will also be posting a video of me doing a recovery. Hope everyone is well. Thanks for tuning in.